People to help me out.
Ooh.
Calling on people who are quiet. Hannah and Honesty. Okay. So everybody needs 2 sticky notes. Okay, so you're going to be given 2 sticky notes. I have a question you're going to answer, and you can answer with words, or you can answer with a picture, however you want to. And here's what you're going to answer. Okay, so I want you to answer, do you think if I started with a domino, I can knock over something that is as big as a building?
No.
I want you to tell me. I want you to draw a picture. If you think I can, I want you to draw a picture how. If you don't think I can, then I want you to say, you can't, Mr. Josh. And then just keep it on your desk. Just keep it on your desk. Okay.
Well, if you made a building.
Voices off when you're answering. All you should be doing is writing. So you're answering. If I started with just a domino, could I knock over something as big as a building or as big as a house?
No.
Okay.
And when you guys are done, you can come up here. And you can sit around. Leave some room for me, but
Can we take a last sticky note?
no, just leave it on your desk.
A doghouse.
Oh, okay.
A doghouse.
Here, here's it.
You can take a note, but it's like a doghouse. And you can drop it over it all.
I'm talking the size of the house you live in.
A doghouse.
You live in a doghouse? You live in a doghouse? Huh?
I used to. No, don't remember.
If it's like big, then you know what I mean? No, like if it's like.
Okay, we're just writing. We'll talk about it.
But this is a giant.
When you're done, just come sit up here. When you all are up here, I'll know you're ready.
Wait, are you gonna watch this video?
I don't like this.
What are we doing with our fingers? I didn't say that you can, because like this is mystery science stuff, so.
Well, you gotta give me a reason. You can't just say it's mystery science stuff. Yeah, if you don't know, just say I don't know.
You could use like a brain and you could pick up the titanium thing, drop it, pick it up, drop it, pick it up, drop it. Okay, I'm gonna watch this first. Because
No,
I said you can. Wait, Mr. Josh, can I say that's when our phones are the lunch?
Yeah, if you guys want to stay at your desk, you can stay at your desk.
What do we do with our sticky notes? I don't want to sit.
Just leave it at your desk.
Okay.
And if you're coming up here, head up here. If you're gonna stay at your desk, just stay at your desk.
No. Okay.
You guys ready?
Go.
Ready, Justin?
I tried spelling destroyed, but.
Okay.
I know.
Hi, it's Doug. Have you ever accidentally knocked something over? I'm sure you have. We all have. But have you ever accidentally knocked over something really, really big? Some years ago, there was this forklift driver who was working in a warehouse in Russia. And he Well, let's just say he did not have a very good day. All of this was caught on camera. Watch what happens.
It was fun. That's a bad day.
Amazingly, he was okay. No one was badly hurt. But it's incredible to see something like this, isn't it? How could something like this happen? Well, you probably noticed he bumped first into one side of the shelves pretty hard. So hard they fell over, and that knocked into the other side of the shelves next to them, causing the whole thing to collapse. The way that one thing knocked over another, and then another, and then another, all of this might remind you of lining up a bunch of dominoes, if you've ever done that. It's a similar situation. You line them all up, and then if you bump into the first one, they all go tumbling down. Stuff like this can be so fun to watch. Check out this example. This was at a library using books instead of dominoes, but it's the same idea. Watch. They line them up, and they just keep going and going and going, all from one little push at the start. Sure, one thing bumps into the next, but why do they keep going on and on and on for as long as you've got them lined up? For example, say instead of books or dominoes, we lined up a bunch of little marbles. You push the first one into the next, and the first few marbles will bump into each other, but eventually they stop. These two didn't get bumped into at all. So marbles don't keep going if you push them, but when you have a bunch of falling dominoes, why do they keep going for so long?
Okay. Raise your hand. So why do you think the dominoes keep going but the marbles don't, Adrian?
Because how the dominoes are flat, like straight flat, and the marbles are round. So when the marble hit another domino, it all keeps going until it stops.
Okay. Honestly, can you add on to that?
I think it's because like the dominoes they are longer, so like they can actually reach the next domino.
Okay. Yeah. River?
Like the marbles are they aren't very tall like the dominoes. They're small.
Okay, so you're saying let me see if I get what you're saying. You're saying because the dominoes are taller, that makes them knock them over?
Yeah. No.
So how come the marbles don't just keep rolling and rolling and rolling? They're round, aren't they? What happens if you kick a ball at recess?
It goes round and round.
That's gonna go round and round. Eventually it's gonna stop.
Yeah, because how much energy it has.
Because of how much energy it has, Sadie's.
Like a marble, like since the ball's the marbles are round, so there's like a thick block to the round, but it's like they go into the area like where a lot of balls are. They're gonna stop because all the area is crowded, so it's gonna stop. But dominoes, they're kind of like, but they go up, but they'll actually like when you push it, they go on top of each other to push that thing down, to push other dominoes down.
Okay. So you're saying because they're tall, they fall on top of each other and then push everything over, and these just crowd each other,
Yes.
and then they can't move?
Mm-hmm.
Okay, let's keep watching.
Well, there's not something special about dominoes. It works just the same for books. Even for lockers. Watch.
Oh no. Your face would be crushed.
Now, as you might imagine, what matters
Okay, so what?
Because it's like how you push, like if you just push all your strength to the dominoes, it goes the whole round.
So the harder you push,
The faster it goes, but if you like push it like not that way, it won't go.
So if you just barely tap it and
Yes.
it falls over, is it gonna push the next one over?
Maybe, but not that. Like not the whole.
Does that work in every situation? You think?
Not.
I think sometimes that can be, especially here. If you ran and you shoved it, like it would probably go a lot faster. But what if they would have barely pushed over the lockers? Do
Barely, but it.
you think they would have still fallen over?
Yeah.
Yeah.
Because some.
Because they're heavy. It's not heavy.
Raise your hand. Raise your hand.
tall.
Raise your hand. Janae?
So whenever it falls, the top part hits the other part, so like it keeps on falling and falling. If you tap it, it goes slow, but it still keeps on going because it still hits it, so it can keep on
Can
going.
anybody add on to that, or just Eliana?
Like because if you just do a gentle tap, it still goes. It doesn't stop or anything because the next one keeps pushing, and not a gentle tap like it was before because it gives them more energy.
Yeah, kind of just like the dominoes.
Yeah.
You push one, or just like in that video of the books, all the books fell over because of that one little push at the beginning. Okay.
Just to having things like lockers and dominoes keep going is that things like lockers and dominoes and books, they're all objects that can be tipped over. And that means that each one has to be set upright. You have to lift each one up. When you do that, you're putting part of each domino up high. You're giving it height. Does that remind you of anything?
Oh yeah.
Do you have any other situations where something is put up high and that does something special?
That's what I put.
Yeah, that's what
Okay. Just a minute. Okay. So I have a book.
That's a big book.
I want you to watch first, and then I'm gonna ask you a question. So I'm gonna drop the book from here. Okay, then I'm gonna drop the book from here.
Hey, don't break the book, man.
Okay.
It's wasn't big.
I know. $2 book.
Oh no!
Oh,
Oh!
Okay.
Stand on the desk.
So, which one had the most energy?
The
tall
I'm looking for people raising their hand. Nola,
It's so long.
when I sit on the chair, why? Why was there more energy? It's the same book. It weighs the same. Did I change the book?
No, but you changed.
Nola. I'm talking to Nola. What? The height. So what was it saying at the very end of the video? The height gives us more what? Energy. Okay, so what are some other things we've done in the past in here that we've used height to store energy? A roller coaster. So with roller coasters, where do roller coasters get their energy? Where's their main source of energy? Damien. Their height. So at the beginning of every roller coaster, or most roller coasters, there's some crazy ones now, but at the beginning of every roller coaster, what is there? There's a huge hill that you climb. They use that energy as they go up the mountain, and then when they come down, that's where their energy is all just coming out. And then as they go up, they store it and go back down. Okay, what else? Have we done anything else that's used height?
What's that?
Yes. When you use the marbles,
Our bumper coaster.
when you release it, it has the energy to go down and
Yeah,
and go
on the little ramps we made.
Yeah.
So on those, the higher you made your thing, the faster it went, right? And the
Yeah.
farther it could go
And then
because
if you make the high, like the one that we did, like if you put one that's really high, it won't at all.
yeah. Okay, so tell me this. So it talked about how the dominoes, the books, and the locker all got their energy from being stood up.
And for being shoved.
from being shoved, but their main energy was when it was set upright. So if I have this book and this book, do they have any energy laying like that?
No.
No, not really.
No, they
But when you stand it up,
it has energy.
there's energy.
You could just knock it.
So which one is gonna have more energy? Jada?
The huge one.
The bigger book. Okay, keep that in mind. Keep that in mind.
I was gonna say the small book.
Yeah.
I was gonna say the small book.
Because it's more.
When you set up a domino, you're putting part of it up high. Does that remind you of anything?
No.
I hope it reminds you of the idea that putting something up high, giving something height, is one way to store energy in it. One example we've seen in previous mysteries was a roller coaster. By moving a roller coaster car up to the top of a very tall hill, you store energy in it. Energy that gets released as the roller coaster car rolls along the rest of its track. But with dominoes, you have to set them up. You have to lift them. Some of the energy you use to lift them up gets stored in the domino. So with this in mind, why is it that when you knock down a row of dominoes, they just keep going and going? Well, the reason it just keeps going is because when you set them up, you gave them height. So you stored them here, here, and here. You stored energy all along the way. When you push on the first domino, at the point that it begins to tip over, you release its stored energy. And as it falls, it transfers some of that energy to the second domino. Enough energy to tip it over. As the second domino begins to tip over, then it releases its stored energy and transfers some of that to the third domino, which tips it over, and so on, all the way down the line. This will happen for as many dominoes as you want to set up. It's fun, and you're probably dying to go play with some dominoes right now. But let me get you to think about something even more surprising. Now, so far, we've just been considering dominoes that are all the same height. Does that matter? Will this only work if they're all the same height? Like, what do you think would happen if we had a...
What do you think? Do you think the height plays into it? Xavier, Zeus?
I've seen videos where they have like small dominoes and like they get bigger ones, and when you tip them over, the more higher it gets, the more energy it's stored. So when you touch that first one, I've seen it like go on and on.
Yeah. Okay.
So the bigger it gets, the more energy it has.
Yeah. So he touched on a really key aspect of this.
I've actually watched the video.
He said the dominoes have what's called stored energy. What is stored energy? And where does this stored energy come from? Honesty. There. You know what stored energy is? What is stored energy?
So if they go up the hill and they lose all the energy and they go back down, they lose more energy.
Kind of. Can somebody add on to that? Trey?
So, like, for moving means, like, whenever you lift it up and you wait for a while, it'll be still there.
Yeah, so like it's energy that like when we stand the book up, the energy is stored in the book. So another example is when do you guys remember when we did the rubber band cars?
Yeah.
What happened when we twisted the straw?
It went.
Raise your hand. Sadie's?
It stored energy because you twisted up and you rubbed it and then you twisted inside. And so before you let go, all that energy is stored into the rubber band, and when you let go of the straw, the energy is coming out.
Exactly. So when you twisted the straw, the rubber band twisted, right?
Yes.
And can you twist a rubber band forever?
No.
No, so it's storing energy and it's getting tighter and tighter and tighter and tighter. The more you do it, the more energy that is stored. and it's ready to be used. Just like as a roller coaster, when it's climbing that mountain, it's storing more and more energy, and at the top you have that stored energy ready to be used. And then it goes down, and then it transfers the energy. So what is transfer? Transfer of energy. What does that mean, Eliana?
Means like when the first one has energy, it takes it on to the next one, and on to the next one, and on to the next one.
Exactly. So when we lifted up the domino, the energy that we used to lift it up is now stored in that domino. And then, how does the energy get transferred to the next domino?
By giving it energy.
Adrian.
I believe it stores energy when you tip it over because, like, when you lift it or use or kick it or anything that you use, it has the energy to move it. Anything that moves has energy.
Okay, so when you let me get this straight. You said when it tips over, it has stored energy, or when it's just standing there?
And it's tipped over. And actually, I meant it's standing.
So when it's just standing here, when this book is just standing here, does it have stored energy?
Yes.
Yes. When I tip it over, does it have stored energy?
No.
Yes.
You're using the energy to.
Okay, so what's that called? It's releasing the energy. So the energy is being released when I push the book over. Okay.
A normal sized domino next to a really tall one.
Oh.
That's how.
All right, we're gonna do this. So I got this. We have this book and this domino, or these are our dominoes today. I don't have a giant domino. I don't know where he would get that.
It's
a box.
Yeah, it's
Make
a cardboard box. It's
basically
basically
a
a
box.
We could make
that
it.
makes sense. Okay, so what do you think? I got this domino and this domino. If I push this over, is it gonna knock that one over?
No.
Yeah. Just
No.
if you push it the opposite side, then it.
Oh, this one's gonna smash that. you
Nah.
think?
Yeah.
No.
Yeah.
The
That's
big
what
one
if you
is
use
that.
the small one to knock the big one.
Eliana.
The reason why it won't knock down is because it's heavier and more stronger than the first one.
Okay. Sadie.
So it won't actually knock down, because like it's little and that one's big, and it won't have enough energy to push the big one down. It doesn't matter the
Okay,
size
let's
of
see.
it. It's weak. I put
No.
it in the little bit that will push the big one. I put that. Do it.
Do it.
Do it.
Ah!
If you use the
It
big
didn't
one,
knock
it
it
has
over.
more energy.
Wait, why didn't it knock it over?
Because it's heavier. That's light and that one's shoving up.
Heidi.
Because that one's small and this one's big, and then when you use that one on that one, it loses energy. You push it, then it loses energy. And this one is just big.
And doesn't have enough energy to store it.
There's an easy way to find out. Let's try it. What do you think is going to happen? Make a guess in your head right now about whether or not you think the tiny domino can push the big one over.
No.
I'll give you a few seconds to think about it yourself.
We already
Nope.
have it.
It's made
5 seconds. What do you think?
Yes.
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 Because the box is
Lower your voice.
wider. Yeah, because it's just.
So you think this little domino can knock this big domino over?
No.
Yes.
Well, I think
Raise your hand made out of paper.
Raise your hand if it's tested.
Raise your hand if it's gonna be no. Why raise your hand if
Lower
it's
your
gonna
hand.
be no. It's a box.
Wait, why do you say yes? Raise your hand. Those of you who say yes, why do you say yes, Jada?
It's lighter.
This one's lighter than that?
Yeah. Yes. No, they're both like the same.
No, they're not.
No, they're not. That one's way stronger than that one.
There.
It's just a tiny one.
Honestly, what do you think?
I have something to say about them. It ain't.
It would.
I don't know because the little one it has less energy because it's shorter. I think that it will because it's just a box. It's really light and basically
Okay, we'll see.
You never know what's in it. You never know what's in it.
We'll see.
True.
Well, did you see that?
Here we go.
Let's see. Are you ready? I'm gonna go ahead and do it now. Let's give it a push.
I told you.
Ah,
Nothing. Right? The small domino had some stored energy from being lifted upright, but it's not enough energy to tip over the second domino. That second domino, because it weighs more and it's bigger, it requires a little more energy in order to get tipped over. But how much energy does it really take in order to tip something over? Sure, a regular domino can knock down a huge one, but could a regular domino knock down one that's only slightly bigger? Slightly slightly. You can use books if you don't have dominoes.
That's like the same,
Okay.
just like 1 inch bigger. Yeah. Yes, it is.
so I have this book.
That's
Do you think this book can knock down this book?
yeah.
It's bigger.
Yeah.
It's bigger.
That's why it's thinner.
So, open up.
It's thinner and it's because it's. That one has one like that.
It's about the same size.
Let's see. Alright, here we go.
Come on, already.
Push.
Just do it.
So why was this book?
Birthday.
Why was this book able to push down this book? It's bigger.
Because it was.
You think it's because it's fatter?
Yeah.
What if I did? What if I did this book and this book?
Yes.
Yeah. I'm saying no to anything. Well, yeah.
Yes.
It can't even stand. Yeah.
Okay.
Well, yeah.
You think so?
Yes.
Push.
So what's happening? Cash, what's happening?
The time.
Is my teacher asking?
The small book shoved over the other book. So it's like this.
Yep, we just saw that. Can somebody add on to that? Trey.
It has enough energy to knock it over because whenever you it's almost the same size.
Yeah.
But one's thinner and one's like.
Yeah. Can somebody rephrase what Trey just said?
No.
Ileana.
Well, it's kind of like, it's thin and it doesn't have like, the big book has like a lot of, it's like really, really thick
Yeah, it's thick and it has a lot of stored.
energy, and then the little ones, the little thin ones, only have like only a little bit of energy.
Yeah. So as you get bigger and bigger, the books have more and more energy. So this book can't knock down that giant book
Because it doesn't have enough energy.
because it doesn't have enough energy. But this book
And knock down that.
has enough energy to knock down this book. Even though this one has more energy, it has enough.
What book is that? Kind of no, not that one.
It's a Christ book.
I don't know.
The one
Okay.
I have it.
So now
We could use those books.
it worked.
See,
We see that at work. Okay, so I want you to go back to your desk real quick. Listen, before you move, don't move. Here's what you're going to do. That other sticky note. Think about now, is there a way we can knock down something as big as a building using just a domino?
Yes.
Draw it on your second sticky note if you think so.
So a domino can knock down a giant big building.
I'm talking like as big as a house. Is there a way?
So
No.
It's the same. It's the same question. I want you to, if you have the same answer, just write same answer as the first one. If you have a different answer, I want you to write how could I take this? Yeah, we're starting this small and we're knocking down something as big as a building.
Okay, so I'm gonna go small to make it bigger.
If that's what you think, I want you to write down what you think. I don't want any words coming out of your mouth. Use what we just talked about. Think about the books. Think about stored energy, transferred energy, and how could we knock down something as big as a building?
Well, can we go bigger? How?
You just-
Go bigger? Wait, how? I thought you could say
You just have to start with this.
I'm going bigger, right? I'm gonna put this. Just because I was gonna be tired. Okay, now I'm gonna put a reason why.
Alright, good.
I put same answers. What if you can leave it like wait, I'm stop. I'm back in one way after yeah. This one I have to do. This one, yes, you can with it.
Okay, when you guys are done, come back to the floor. Whoever was sitting on the floor.
I have no idea.
Time is lunch? I don't know. 11:30 or 11:45. Oh, 10:40.
This is what I put. I know.
Light? Heavy?
Because I can light.
Light.
Yeah. Why? Well, at least 2 times.
Oh, yeah.
He said that he's gonna go bigger. He's gonna go bigger. Like a whole box of dominoes.
How much energy does it really take to knock something over? Sure, a regular domino can't knock over a huge one, but it can knock over one that's slightly bigger. Other people have noticed this before and wondered, what if each domino you set up was just slightly bigger than the last one? Like this setup you see here. Now,
Yeah,
you
that's
think a domino could be used to knock over a
Yes,
few
it
other
is.
ones?
Yeah.
This is a science teacher who's trying. Now, look how he's got it all set up here. Are you ready?
Yeah. This is a video that I watched before. Do it.
Ooh. That worked pretty well, but could we do something more impressive than that? Could it be possible to knock huge,
Probably underwater.
something as tall as a boat?
Sadie. If you're done, come to the floor, please.
Do we have to go down?
Blink even? Let's see what happens when some people try this.
Whoa. Oh,
What
yeah.
you can see is the Guinness World Record for the
Wait, you think that's gonna work?
Yeah.
That's what I said.
Why?
But
Adrian.
what if it's gonna cause a tsunami?
But look,
Oh my gosh. Peyton waited till
they have a tiny domino.
he waited till
How are they gonna knock down that thing?
he got
Because if it's small and then medium and bigger and then bigger and bigger and bigger, it's gonna work.
Can you add on to that?
It's data.
apparently when they get bigger it has more energy. He said the big giant
More
more
data, the more energy it has.
and more height.
Okay, tell me this. Does this domino have energy?
Yeah.
It does. Does it have a lot of energy? No, it doesn't. But if we have a domino that's bigger, that has more energy, and this domino can knock down that domino. And then that domino can knock down a bigger domino, and then a bigger domino, and then a bigger domino.
I've seen this one, that's what I'm saying.
You've seen this work?
Yes.
Domino to be toppled over.
Time
Look at how big it is compared to these people standing back here. It's not quite the size of a building, but it's at least the same height as a small house. You see this one in the background? Okay, watch what happens when they start with the small domino. This huge domino at the end gets toppled over, all with the start of a single domino about the size of a brick getting knocked over. How is that possible? Can you explain what's going on in terms of energy?
Okay. So what is happening? I want you to use science words like stored energy, transferred energy, energy. Explain to me what's happening, Trey.
So, whenever you, the small domino has, a little bit of energy. So, the big domino, whenever that domino does that, I think it uses more energy, and then more energy keeps going up.
Yeah, and that's called, starts with a T.
T?
Transportation energy.
Transform.
Like you're transforming the energy, or you're transferring the energy from one domino to the next. That's why every domino is able to fall down. Like if you do a huge line, that's why they're all able to fall down. Because when this domino hits the next one, and then hits the next one, the energy that's stored here is being put into the next domino. Just like when I pick up this domino and I set it up right, the energy that I used is stored in the domino. So when I knock it over,
I lose his energy.
Now,
I put the energy into the next one. And just like we keep going up, just like they did. So they start small, and eventually you get bigger and bigger and bigger and bigger.
Until it pops.
Yes.
there's like a bunch of, there's height, because of the height, it matters, so whenever you tip it over, it gets more energy so that it falls, and because of energy, because the energy saves it up, and then once it tips over, it uses the energy.
Yeah, because like at the beginning we talked about how height helps us do what? What does height help us do? Well, like what had more energy when I dropped the book? When I dropped it from here, here, or here? It was the tall one. So the more height, the more energy, right? So the taller the domino, the more energy it has.
Okay, yeah.
So it is his fault. It ruined it. He was the last time he used it. It's his fault.
Hey, are you ready?
Yeah, Mr. Josh is finishing his lesson. I just texted Mrs. Peter.
Hey,
So when you have that, it's called a chain reaction.
What's a
This
chain
is
reaction?
the last one.
Oh,
So a
I
chain
know what
rea-
a chain reaction is.
Adrian, what's a chain reaction?
A chain reaction is like, let's say that you put something on a seesaw, and you put something bigger, and you let it fall, and that thing that stores it, when the thing hit the seesaw, the thing from the other side lifts it up.
Yeah. So we have one thing that starts, like we have the first domino, and then it knocks over the next one. So it's like a series of events that lead to like an end, like here. Well, what's this one? This one is just, this is the last one.
Dominoes aren't the only example of a chain reaction.
Whoa, that's cool.
This guy is named Joseph Herscher, and he's an inventor. He invents machines. But these machines aren't meant to be helpful. They're meant to make you smile. It's a chain reaction machine. Check it out. So this is an example of a chain reaction machine invented by Joseph Herscher. This one is meant to help keep him awake when he's at the office. Now, do you see what he did here? Think about everything you just saw. But let's watch it again. This time, pay attention to where the energy is stored and transferred.
The bucket. Then his hat
Don't
has
the
a string.
pulley. Don't forget the pulley.
So just like with dominoes, in a chain reaction machine, if you go back in time, there are places where energy is stored, just like you see the energy stored in dominoes. Even though Joseph didn't use dominoes in this machine at all, he did use height to store energy. Like, check out this part. Notice the hammer? It's been lifted up like a domino and is now standing like it could topple over. It has energy stored up. Watch when the ball hits it. Now, speaking of the ball, it's high up too on a ramp. So it has stored energy and is ready to roll. Watch.
He hit.
All together, the ball high up on the ramp, the hammer standing up, have enough stored energy to send this orange ball back here flying. Watch one more time. See that?
Yeah, 'cause the
So
ball-
chain reaction
the ball
machines,
has something
they're
on
mostly
it.
just for fun, but there's one way that they are actually useful. By looking at them and playing with them, you can figure out different ways energy can be stored. And by watching all the parts move, you can also figure out ways energy can be transferred from place to place. As we're going to see over the next few mysteries, chain reaction machines can help us understand how our own real-world machines work. We'll see that in the real world, we have to find ways to store energy, and we have to find ways to transfer that energy from place to place in order to power the moving parts that we find in our homes, our schools, our offices, our hospitals, and more. But for today, you're going to think about how you can store energy to make a chain reaction machine go. Have fun.
Okay, so I think tomorrow or whenever you guys do science next, you guys are going to make a chain reaction and you're going to use the idea of storing energy and transferring energy.
What do you mean tomorrow?
I don't know.
You don't have to go
Monday.
tomorrow.
Oh wait, yeah, you guys aren't here. On Monday.
Yeah, but we don't have science.
Yeah, we do. skip?
No, we don't have social
This is
studies.
science. This is that.
And we don't have quantity.
Yeah, but we have science last.
Yeah, but
So-
we didn't really have science last week.
Yeah, so it's, we don't have. So now we don't have
Okay,
social.
what do you tell Mr. Josh?
Thank you!
How did you do?
This is
Good. 100% good.
It was
You
did
bad. You did horrible.
Okay, guys, we need to line up.
I
to
get
go to
it.
the Let's go. I just said that. Okay, 5, 4, 3, 2. Well, then choose a different girl.
It's me.